All right. So this is the building numeracy with problem strings. My partner, Krista Patterson, was supposed to be able to do this with me, but she had a family emergency at the last minute. And so you just get stuck with me today. But I'm really excited to do this work with you. I am a math teacher and instructional coach with Minneapolis Adult Education. I'm also on the Minnesota Adult Numeracy Advisory Team. So for this session, we hope to accomplish that you get to experience at least you get to experience problem strings as a participant. Afterwards, we're going to kind of talk through like what it was like to experience that as a student, and then specifically talk about some teacher moves and what strategies were covered during those problem strings. We're going to give you opportunity to be able to reflect on the experience and determine like what next steps you want to try and explore some resources. Some of them are free, some of them you do have to pay for, but on the free resources, you can access ready-to-use problem strings. So before we go any farther, we wanted to have you kind of meet some of your colleagues. I know you've gotten to spend a lot of time today being able to do some whole group work, being able to do some breakout room group work with people. And so in this space, we wanted to kind of find out who's here. So if you can, in the chat, please put your name, any other identifiers that you'd like to share, what program or site you are from, what math content or level you are teaching, and what you are hoping to get from this session. And maybe what math concepts do you and your students struggle with? All right, Justine, no worries. If you haven't gotten a chance to yet, I suggest you scroll through this chat and kind of check out who's in this room with you. Who are we sharing this space with? Well, Olivia, I hope to definitely target your desire of a routine that's relatable and that can help students who struggle with fractions. Oh, okay. Thank you, Jamie. All right, so I think I've gotten to skim through and at least read almost what everybody has said. Some of the things that I'm seeing that a lot of people are working with GED level. We have a few ESL level teachers in here. People are wanting to be able to make or help students be able to read and understand like if they have story problems or word problems. How do we help students improve their skills? How do I help them know what steps to take? So I want to kind of just talk about the fact that what a problem string is even, and that will hopefully kind of help connect things. So a problem string is an activity where a group of problems are presented in a very intentional order to develop relationships between numbers. Okay. And they are very intentionally written to help develop certain skills within for students. And I'm going to give you 3 opportunities during this presentation to experience them at varying levels for the CCRS levels. And I'm hoping to at least hit everybody and like what their needs are. If I did not, please do reach out and let me know what questions you still have, and I am more than willing to help you in that. So I'm going to ask you just to be a participant first, okay? I'm going to ask that you kind of throw aside any algorithms that you're typically used to using and really think about the numbers that are in these problems. And I encourage you to, as it says here, do some mental solving. You're going to mentally solve the problem and type your answer in the chat. I'm going to ask that you do something called waterfall, where I'm going to have you wait to send your chat. And you can type it in, you can have your answer ready and your thinking ready if you want to include that. But I want you to wait until I ask you to send it so that everybody can get them some think time. I also want you to be prepared. So if you have your answer and you've typed in the chat, I want you to be thinking about how would you talk about how you got to your answer? How would you share your thinking with others? Okay, and then I want you to be prepared to listen to others' thinking. So your job is going to be to come up and think about the problem. Once you arrive at an answer, you can type it into the chat, but wait to send it. And I want you to be prepared to listen to others' thinking. And if I ask you to be able to either ask another participant a question or to be able to restate what you understood of their thinking. Okay, are there any questions about what I expect from you as a participant before we begin? All right. We're going to get started then. So for this first problem, I'm going to ask you to be patient with me because this is not my preferred platform, so I'm less comfortable on it while presenting. Okay, so the first problem I'm going to give you guys is 37 minus 10. All right, type your answer into the chat if you haven't yet, and then you guys can hit send. All right. So I'm seeing that 27 seems to be the answer that you guys are arriving on. I want to ask, let's say, if I say your name incorrectly, please unmute and correct me. Tav, you typed in the chat, take away or subtract. Can you unmute and tell me more about how you arrived at your answer? Is it Tave?
It is tough, but
Tav.
I don't
Okay.
know why he's not responding. I work with him. Tough
Okay.
is good.
Maybe Tav can't answer right now. Gloria, since you had unmuted, would you be willing to talk to me about how you solved this problem?
I just took away 10 of 37.
Great. So we are going to, you started with 37, and then you said you took away 10.
10.
And you landed on 27.
Yeah.
Okay. Thank
Tab
you
just,
so much.
yeah, Tab just answered. He said he's having audio problems.
Oh, no problem, Tav. Thank you so much. And
Yeah.
thank you, Gloria.
Yeah, you're welcome.
All right, so again, I just want to reiterate. So we started at 37, we took away 10, and we ended up at 27 here. Awesome. All right, next problem. What would you do for 37 minus 9? And I want you to think about how could the problem before help me think about this new problem? All right, go ahead and type your answer into the chat. I gotta admit, you guys, Zoom is not as user-friendly for me as my regular platform, so it's taking me longer to navigate chat and the screen. Kevin Bardish, would you unmute and talk to me about what you did?
Yeah, so the strategy sometimes is when you're subtracting 9, you can subtract 10, but then give 1 back. So we have 37 minus 10. Our previous result was 27, but give 1 back would put you at 28.
Okay, would somebody be able to unmute and explain why are we giving 1 back? I thought we were doing subtraction here. Danielle, would you be able to unmute and talk to me about why? Oh, great. Now I lost your name again. I'm sorry.
Katie, I'm here. Are you talking to me?
Yeah, so Danielle, can you please explain to me why Kevin ended up saying we can add or we're putting 1 back? Why are we adding 1 if we were supposed to be subtracting?
Because we're taking 1 less away.
Thank you.
Yeah, right. I was going to be a smart aleck and answer, and so I just counted on my fingers.
Not helpful, Danielle.
But I didn't. But yeah, because since I think the concept is since we took 10 away the first time and we got 27, like, oh, I'm taking 1 less away. So now I have $28 left instead of $27 left.
Great. Thank you, Kevin, and thank you, Danielle.
But it is confusing because if you say, you know, I took away 10 and I need to take another one. So it's in my mind, I'm thinking I'm taking away another one. So it's not 27, it's not 28. To me, it would be 26. But it's wrong. I know it's wrong. It's depends on how your mind works. You know, if you don't have a math mind, then you're gonna be all confused by what is more, what is less. I don't know. Because I hear you saying less and less, and I'm thinking, what then, why are you adding 1 more to make it instead of 27, 28? If you say less to me it's 26, I know it's wrong, but I don't know if it makes sense or not. Probably not, but I had to. That's what happens to our students. You know, sometimes they confuse with even before or after, more or less, and what is in their brain.
Gloria, thank you for sharing because this is actually something that comes up when I do this work with my students all the time. And so, Danielle, can you explain when you said it's 1 less, which to Gloria means, oh, you're going to take 1 more away rather than to add 1. Where's the 1 less coming from?
So I think we could look at it like instead of taking 10 steps back on my number line, I'm taking 9 steps back instead. So I'm actually kind of with her, like for me, like that doesn't work great to like I take when it's a 9, I'm the same actually. I kind of get confused. I'm like, okay, am I gonna put one back the other way or this other way? But when I see it, like right now, when you make a number line, then I was like, oh yeah, then it's being the very visual person, it's like, oh yeah, instead of going back down to 27, I'm just gonna go down to 28. Yeah, like that. So
Mm.
if I have to just do it in my head, it actually not so good, not so much.
Gloria, did that help at all?
Oh, yeah, definitely. And now that you see that blue, I see that blue -9, it makes more sense than just the 1. You're taking away the 9, not the 1. I don't know.
No,
Yes.
and
Thank
this is something that comes up all the time with my own students. And so the idea of if we take away 10, and for some it comes really natural, like, oh yeah, I'm taking one less away.
Yeah.
So in other words, if I'm taking one less away, I've taken away too many things now. And so I have to add one of those things back. And so really what I did is I subtracted 9, but doing -10 and adding one back is easier for some people to do.
Or
So
like the other
Gloria, you
person
might be
said,
thinking, is this something that you want your brain to be able to do like more readily? Hey, I want my brain to be able to do that.
definitely.
Nice. All right, next problem. $73, take away 20. All right, type your answers in that chat, hit send. Sorry for the very not straight number line. All right, so I see that many of you guys have typed in 53.
Mhm.
And
See, there is somebody who says 70 minus 20, but then you add 3. It's okay. I think I'm gonna open my camera.
okay, so I see lots of different ideas in here. Susan Clark says you're going to do 53 and you're going to count down by 10 twice. So we're going to, again, thank you for your patience as I try to navigate these tools. And that was way too big of a jump. Make sure if you are making this visual for students as they are sharing their different ideas, that you are also being very accurate with how you're representing things. Oh, I did the numbers wrong, didn't I? Huh.
Oh, sorry, 3.
Larry, do you know that you are still unmuted? All right, so by subtracting 2 groups of 10, I am actually essentially subtracting 20, and I land on 53. All right. Next problem. What about 73 take away 19? All right, type your answer into that chat box and hit send, please. Oh, I like that more and more of you guys are typing your thinking. Right, Susan. Okay, Christy. Paulina, would you be able to unmute and talk to me about what you did?
Sure. Well, based on the one that we did before, 37 minus 10 and then 37 minus 9, I'm seeing the same pattern, right? So I understand that 20 is 2 groups of 10. So 19 is 1 less than 20. So I'm going to take that 1 and add to the answer 53, and I would get the answer 54.
Nice. I see that many other of you guys also did that this time. I'm gonna be totally honest with you guys. Typically, this actually moves much faster because I'm much more comfortable with the tools on the board. So we're gonna do one more problem in this string. Thank you, Paulina. All right, last problem, 63 minus 28. And as you're thinking about this problem, I want you to think about, is there anything from what we've already done that can help you think about this problem? Great, hit send if you've typed your answer into the chat. All right, so looking through the chat, I'm seeing that you guys are arriving at the answer of 35. And when I look at how people are telling me they did it, I'm loving all the different strategies. This is very, very clever. All right, let me see here. Susan, I haven't heard from you yet. Would you unmute and talk to me about how you solve this?
Oh, sure. 63 minus 28. I think in my mind, I rounded 28 to 30 and did that in my head and then added 2 back.
So you rounded it to
The
30.
28 to 30, yeah.
Took away
Subtracted.
30.
So I got 63 minus 30 is 33, and then I needed to give 2 back.
Great. All right. I want to just make sure I didn't miss anything else in the chat. You guys are all very clever. All right, so, this, in this problem string, I've, given you guys a chance to visualize, some thinking here. And something I forgot to do, and I apologize for that, was at the end here, we ultimately ended up just adding 19. And here you just ultimately ended up, I'm not adding, subtracting. Oh, geez. And then here you also ended up subtracting 28. All right. Oops. Sorry, you guys, I am used to everything disappearing when I'm changing slides. Here we go. So we're gonna shift gears now. That was working on a subtraction problem string. We are gonna shift gears, and I want you to think about a bag that you travel around with. Do you ever have anything small but you might use with a group of students that you keep in your bag? And if so, like what small items do you use with students or with your colleagues? Type your answers into the chat, please. Maybe you carry on a backpack, maybe it's a purse. Coins, dice, playing cards, Post-its. Jamie, that's one I didn't anticipate, but that's a good one. Ooh, mini whiteboards and markers every day. Yeah, my students like those too. Ooh, rubber bands, okay. Popsicle sticks. Ooh, for ESL, having letters in the bags to work with making words. I like that. Legos. Oh, my kid loves Legos. All right, so these are all great tools to be able to use with students, right? So today, one of the things I didn't do in the first string is I didn't give you guys kind of a story or any context around the numbers. So it's gonna be different this time. So I want you to think about a deck of cards. Okay, so, and I want you to think about like how much do you think a deck of cards weighs, you guys? Any ideas? How much does a deck of card weighs? Ooh, 3 ounces, 4 ounces. One metric or standard? Okay, that's very good. How about in like ounces? Less than a pound, nice. Maybe 2 ounces. Who are now in grams. All right, so a typical standard deck of cards weighs actually about 3.2 ounces. Okay, or 3 2/10 of an ounce. And do you guys use, if you use decks of cards with your students, what kind of things do you guys do with them? Ooh, counting games. Oh, probability. That's a really good one, Jamie. Well, you know, that's really interesting because that's not what it told me a month and a half ago. Ooh, multiplication of integers. Okay, and you don't use them. That's okay. So for this, I want you to be thinking of a deck of cards. And Google told me a month and a half ago. Oh, hold on. Something happened. That's interesting. Google told me about a month and a half ago that a typical deck of card weighs 3.2 ounces. And so due to that, we created a problem string around it. So to help us kind of keep track of information, I'm going to use decks of cards, number of decks of cards, and we're going to track this. And we're going to say weight. I'm going to track it in ounces. Okay. So we said already that one deck of card weighs 3 2/10 ounces. Cool. So how much, and again, type your answer in the chat, but wait to send it. How much would 2 decks of cards weigh, you guys? Think about it, think about it. Type your answer into the chat and please hit send. All right. So 2 decks of cards we have said is going to weigh 6.4 ounces. And Adam, you said multiply each number by 2.
Sorry, can you say that again?
Yeah, so can you tell me exactly like how'd you get from one deck of card weighs 3 2/10 of an ounce to 6 4/10 of an ounce?
I did them separately, 3 times 2, and then 2 times 2.
Okay. So that's what you meant by multiply each number. You were thinking of you doubled the 3 and to get 6 and you doubled the 2 to get 4.
That's right.
Okay, nice.
Thank
How many of
you.
you guys look the same way as Adam? Oh, Adam, you're the only one that did that way. And Adam, how did you know that you could double each of these numbers to get the right answer?
Looked at the number 2.
This 2 right here?
Mm-hmm.
So like you were thinking, okay, if I have one deck of cards, it's this much, and I'm doubling the number of decks of cards I have, so I can double the weight.
Yes.
Okay, cool. All right, next problem. What happens if I have 4 decks of cards? How much weight is that going to be? All right, type your answer in the chat, please. Olivia, can you tell me how you found your answer, please?
Well, I noticed that the 2 is just being doubled again on that left side. And so I did the same thing with the 6.4. There's a definite pattern going on here.
So if I have twice as many decks of cards, my weight is also going to double.
Correct.
Okay. What about if I have 8 decks of cards? How much weight is that going to be? All right, hit send, please. All right, so it looks like we have a couple different answers here. Oh, nope, I'm looking at the other. All right, so these are the answers that I'm seeing. And let's talk about how we got to these then. So I have this as one answer. I have that as another answer. Oh, and I can't scroll while writing. Hold on. I know I saw another one. So every time somebody types, it keeps scrolling down to the bottom for me automatically. Okay, that's the other one I saw.
Someone also had just 25, I think, too.
Yeah. Oop, I did a percentage. That is not what I wanted to do. It's supposed to be a question mark. No wonder people are confused. Okay. So I always put question marks when I have like various answers there because I want my students to know that, well, I don't know which one yet, right? So let's talk about it. You guys keep typing faster than I can read. Oh, Patricia, can I have you unmute and talk to me? Because I see that you've changed your answer.
Yes, because when I first looked at it, I was thinking 8 times 12.8. And then I rethought it and I was like, no, that's 8 times 3.2. Because I was timesing the last number instead of looking at it from a different perspective. So,
Okay, why do you think you times the last number?
so, well, if you go 8 times 3.2, then you come up with the 25.6. So I
Okay.
used the wrong number to multiply with.
Okay, so it was just a mistake. You went. Okay.
Right. But that's an easy mistake to make because if you are doing that linear thinking or your thinking string, you're thinking I've got to multiply. And then what we were doing is we were doubling up the number every time. And now we had to rethink that. So,
Okay.
right. And so that's sometimes how students make mistakes is because I am ADHD and dyslexic. So sometimes I will make that choose that wrong number and I have to go back and rethink it.
Nice. So what made you rethink it?
When I thought about it, I was like, wait a second, that just doesn't make sense. That 102 just doesn't make sense. So let me go back and look at the problem again. Oh, yes, I remember that 8, one card is 3.2. So,
okay. Kevin, thank you very much.
You're welcome.
Kevin, can you unmute and talk to me about doing this doubling thing again? You're saying that we can double this again, but I thought that somebody just said we couldn't. So I'm curious. Can you talk to me about how you got your answer for 8 decks of cards? How much would 8 decks of cards weigh?
Sure. So I'm seeing a pattern that you're giving us in the number of decks of cards 1, 2, 4, 8, and through my number sense, I know that 1 doubles to 2, 2 doubles to 4, 4 doubles to 8. Even I guess just going from the 4 doubles to 8. So if you double the decks, you'll double the weight, you'll double the ounces, and then I did some mental math, doubling the 12.8 to get the 25.6.
Right. All right, so based off of what I've asked you guys so far, what do you think the next number of decks of cards that I'm going to ask about is? You can type that in the chat. What do you think the next number I'm going to put for the number of decks of cards? You guys would be correct if I am going to continue to do this idea, but it is not what I'm giving you now. What about if I have 10 decks of cards? 10 decks of cards, how much is that going to weigh? 10 decks of cards. When you're ready, you can type your answer into the chat and hit send, please. You guys are creative. All right, Adam, can I have you unmute? I would like you to talk to me about your thinking there.
All right, I did a typo, but well, I know that I learned multiplying by 10 is so easy. You add a 0, and then in the case of if you have a decimal, you move the decimal point 1 to the right.
Okay, so I want to make sure I'm hearing you correctly, and I'm sorry.
So the answer is 32 ounces. I'm adding a 0 to 3.2, but then I'm also need to move the decimal place 1 to the right.
Okay, and you said why? You said you were first multiplying by 10, right?
Uh-huh.
Okay, why did you multiply by 10?
As opposed to what?
Well, I said I have 10 decks of cards. How much would that weigh?
Yeah. Why did I multiply?
Yeah.
That seemed the only logical answer.
No, but like, so why did you multiply it by 10 in particular?
Because you wrote 10 there.
So I did, I said to do this.
You wrote 10 in the, I don't understand what you're asking.
That's okay. Oh, I think
You wrote
Olivia
10, right?
might have an idea. She says that one deck is 3.2 ounces or 3.2. So 10 of them would be 10 times 3.2. Is that what you were thinking, Adam, when you were doing your problem?
Yeah, but your question is why did you multiply? And that answer doesn't answer why. It just answers with the process.
It gets behind the thinking. So you were thinking, okay, well, I know that one deck of cards is 3.2 ounces, right?
Mm-hmm.
So you know to get to 10 deck of cards, I'd have to multiply by 10. And that's what you did, correct?
Yeah.
Does that make sense?
That
Be
makes
honest,
sense.
if you're
Yeah.
like, no, that's okay.
I mean, that's the only thing I know how to do. That's, yes. So whether it makes sense or not, I don't know.
Okay. I appreciate your honesty. So when I'm doing the problem strings, I'm very much asking participants and students, okay, so if you're choosing to multiply by 10, I want to know why. Why did you make that choice? And so you needed 10 times as many decks, and you know what one deck weighs. So you need 10 times as many to get to the weight of 10 decks of cards. Yeah.
And yeah, tell me more. Like because we've done this every time now.
Mm-hmm.
Where are we going with the principle?
Yeah, because
Right.
I also thought that we were multiplying every single time. So I'm not sure why we're asking why we would multiply by 10, because we multiplied three times 3.2 by 2, right? And then we went to 4 decks, so then we multiplied by 4. So when you ask us about 10 decks, we just multiplied by 10. I'm a little confused as well.
So each of the times that you guys were doing this, you were scaling up by the number of decks more that you have. It sounds like, Polina, you did 1 deck the first time, 2 decks the second times. Then you multiplied, you said if you started with 1 deck and you had 4 decks you needed, you'd multiply by 4. So you'd multiply the weight by 4. And I'm seeing that relationship there. Other students were seeing that, oh, I can take the weight ahead and I can double it again. And I can double that amount. And so if I'm doubling, I'm not multiplying by 10, I'm not multiplying by 4. So if I asked why you multiplying, I
Yeah.
apologize. I meant the question to be why you multiplying by 10 specifically.
And instead of 2.
Yeah.
Got it.
So why is 10 the number that you picked out to use as your multiplier? Because remember before another student or another participant had said that they had 108 as an answer. And then when she went back and thought about it, she was like, oh, I multiplied 8 times 12.8 ounces instead of thinking 8 times 3.2 ounces.
It was just the easiest way.
And I think
Nice.
they are, so like just listening to you, I think there are 2 ways that we were all solving it. Like, right? So some people were doubling and some people were multiplying. So when you ask why you chose multiplication, in my mind was like, well, because I multiplied every single time. Right? And then but you were asking why I chose multiplication because people were telling that they were doubling. Is that what you mean?
Closer, yeah.
Okay.
Yeah.
All right, thank you.
Yeah. I also noticed in this chat that some people actually didn't multiply to get this answer. Gilbert, are you able to unmute and tell us how you solved this? Because your way was very different.
Yeah, I just looked at the answer where we from previous and added the answer to 2 because 8 and 2 is 10. And the sum of both of those would give me the answer for the 10.
So it's just in different colors. So she said, I know that 8 and 2. Oh, my
The
pen's not
answers to
working.
those 2. Mhm.
Oh, come on. Sorry. Technical difficulties. So then you took the answers from those and you
Yeah,
added those.
which is longer than what you guys did. So way to go, Adam. You did great. Because sometimes when you're teaching students, they can visually see that. And this, if you do just multiplying 32 times or 3.2 times 10, sometimes the students don't always understand that concept. So this was easier for me because that's how I teach some of the students. I mean, but if somebody else came up with that, you let them share it. But this is just a tangible, I see this.
Nice. And you used information you had already figured out to help you solve a problem that if you didn't, so for some of my students, they honestly do not understand why when you multiply by 10, a number
Right.
gets bigger. When you multiply by 100, it gets bigger. Like they know to add a 0, but they really don't know what that means. And so that
Right.
doesn't help them actually solve a problem, especially if they don't know when to use it correctly. And so then Adam knew that though, like he owned that, he knows that when I multiply by 10, things are going to get 10 times bigger. And so he owns that fact. So that was the easiest way for him.
Right.
Adam, I see that you put, now I'm questioning everything. Can you unmute and what's going through your head right now?
Oh, I was just being facetious.
Oh,
Adam, you're just one step ahead of me.
I don't know. I think I'm parallel to you.
Adding something? My name is Tong Tao.
yeah.
As a problem like this, we can see the pattern also in my class as I give them foundation, background knowledge, everything. Then when a problem like this, I get to my student, I just told them that they can use ratio proportion to solve for how many ohms. So let's say we know the equivalent is 1 deck of card equal to 32 ohms. I mean 3.2 ohms. And then we say, okay, it's 10 equal how many ounces, then they can set as proportions, because it's just like very similar to blueprint, as we talk about like what's supposed in the blueprint is 1 inch is equivalent to 3.2 feet. So if it's a 10 inches equal to how many feet? So I can you get them as one way to have them to do is that think about proportions, racial proportions, and have them to do that. But like this problem, as we see in this, just like any other you guys was doing, is that we just see the pattern and we just adding like other, they say, okay, 2 deck of the card plus 8 equal to 10, then we take 6.4 plus 25.6 will equal to 32. So there are many different strategies, there are many different approach. So in this, if we see the pattern, we can do many different ways to get the answer.
Beautifully put. Beautifully put. And this is very rich with proportional thinking throughout it. All right, I'm going to give you guys 2 more problems. And these we're probably going to go through just a little faster. So if I have 100 deck of cards, how much is that going to weigh? Thinking. Type your answer into the chat box, please. Nice, I'm seeing 320 ounces. What about 99 decks of cards? What about 99 deck of cards? How much would 99 decks of cards weigh? How could some of the things that we've already used help us figure out that problem? I don't usually talk through all your thinking time, so I apologize. If you're ready, type your answer into the chat, please. I'm just looking through the chat and everything you guys are typing in there. Nice. So it looks like a lot of you guys were able to see that connection there. I gotta tell you, it is a hard connection for my students to see. Being able to see that, okay, if I take 100 decks and I subtract 1 deck, I get 99 decks, which means then I have to take the weight of 100 decks and subtract it from that 1 deck. So I have 1 deck less of cards, right? To get your final answer. But when students do it, and they see that, and then I point out to them, hey, guess what you guys just did? They are amazed because they did it usually pretty fast, right? They were using what they already know. And they're not setting up with an algorithm and thinking about, well, 9 times 2 and 9 times 3 and add that to 90 times 2 and 90 times, like they're actually thinking about how large 100 deck of cards would weigh, how much one deck of card would weigh, and then how much, like if they take that away, they're making sense of the actual problem when they're using these strategies that you guys just used, right? They're not just putting numbers and calculating. And so that was something that I think a lot of you guys were talking about wanting students to do. Astrid and Gail, can I get a time check? When am I supposed to be done again?
3:30.
Oh,
3:30
okay.
is the end time.
I was
Yeah.
worried it was
And
3.
No, let me see here. Yes, 3:30 is your time.
Okay. Okay, we're gonna do some reflection now. If I can get my slide to advance. Oh, hold on. There we go. So I want to check in with you because you guys had some really good discussions and like pushed me as a presenter in doing the problem string, which is what I want. I want to be able to grow and I want to be able to help facilitate hard questions. And so thank you. I wanted to know, how did your thinking change as you progress through the problem strings that we've done? What did you notice about your own thinking? Type your answers into the chat, please.
Kathryne? Is it Kathryne?
Yep.
I have a comment to make.
Yeah.
Personally, you know, after a while I was checked out. And I try to follow all the string, but also I have to share with you that most of our students are not used to this system, the ounces. So I'm a language learner myself, so we don't use this system. We use the kilograms and milligrams and liters and those things. So what I have to do most of the time when we do math is just we need to review and do the equivalence, you know, of not the equivalence, but, you know, explain what is this system, you know, they use in the United States and in the United States, because I think most of the countries, they use the other. And I think Paulina mentioned it was, she said the metric system, or at the beginning, I don't remember what she used. I don't know the name of the two. But anyway, yeah. So that when it comes to these situations, is I think it's a little harder, even harder for the students to try to cope and get, you know, these ounces or pounds. But anyway, that's just a comment that I wanted to make. But like I said, personally, after a while, after maybe the 10, then I was like, I don't know if I should switch it to, you know, it became foggy in my mind, to be honest. So, but that's me.
So Gloria, what was tripping you up? Was it should I still be talking about, you know, 320 ounces, or should I now convert this to pounds, or what? Is that what was kind of foggy for you, or was it the actual methods and strategies used to solve the problem?
Yeah, try to convert, you know, like from the ounces, you know, because I know that there is a point that you need to switch the ounces to the pound, because so many ounces can make, you know, in weight. But, you know, it's okay. It's just, for me, it became a little confusing. I tried to follow you. I follow all of them, but I didn't know. I was confused about the answers. I didn't really have a right or an exact answer myself. So, but I was thinking about the students more than me. You know, how do the students try to cope with this when it comes to this different system they use in their countries and they use here. That's it.
Thank you.
Yeah, you're welcome.
Can I say something? In my class, I taught my student both the US measurement and the metric system, and then I also taught them the equivalent between US and metric. So they kind of make sure that before that's the prior knowledge before doing any problem related to ounces or gram or milligram or meter, anything like that, to make sure they understand the prior knowledge, so they understand the difference between US measurement and metric measurement and the equivalent. So they kind of get the idea of when we talk about this much, like for example, this much gram is equivalent to this how many ounces. So that's one of the things that probably as an instructor or teacher, we probably make sure they understand the prior knowledge before we give them the problem.
Oh, very good points. And I trust that you guys all know your students best. I assumed, and maybe this was incorrect, that the majority of you guys would be able to think about things if I gave you ounces and be able to think about it. And I didn't ask you guys to convert. That is actually another layer that I could bring in to the problem string and ask about as going through it. An extension question that I could ask is that, okay, I can only bring 20 pounds more if I was going to travel. Let's say like I was going on an airplane and I was going to a conference and I need to bring decks of cards to be able to do my session at a conference. If I'm traveling, I have to consider, okay, if this is how much each card weighs, or how much each deck of cards weighs, and I can only bring up to 20 pounds onto the plane more without having to pay a whole bunch of extra fees. Now I have added another layer to that kind of problem and thinking. And so I wasn't asking in this specific problem to think about converting, just because I didn't want to add another layer, because I have teachers in here that I knew could be you know, working on numeracy just in their core ELL classes, or you're in a one-room schoolhouse and not all your students are in the same place. And so I wanted to make sure I'm getting hitting the different levels for teachers as to what they're teaching and what they're wanting to work with. But again, I trust that each and every one of you are keeping that in mind as you know your students best. I really enjoyed reading through what you guys were saying about how your thinking changed, the things that came up in your mind as you were doing this, especially from a student perspective. And some of you have already brought up from a teacher's perspective what you were thinking about that you would have to do, or what you have to think about so you could possibly do this with students. And so I wanted to talk about, like, what strategies did you use during this problem string? And I know some of you guys have already said them. I know that I heard doubling come up. Something that some of you guys were doing was something called smart partial products. I'm sorry, partial products. The smart was a typo. I apologize. When you guys were adding the 8 decks together with the 2 decks, that's using partial products. when you guys use the 10 decks to be able to think about 9 decks, you are doing an over strategy, and that's something that we used with the subtraction problem string as well. And this was a problem in the problem string. I didn't give it to you guys due to time. Oh, no, that's all I have, I guess, apparently. Oh, no. Okay. So yeah, and we didn't do this one because of time. That didn't come up. But one of you guys had asked, like, what is the point of the string kind of, and what we were working on? And in this particular string, because a lot of different strategies came up, the goal actually wasn't the strategy, it was using a ratio table. So, oh man, come on. Nope. This is where I miss my own platform that I use, because I'm much more efficient at it. Come on. I apologize. I had to erase it and I forgot that it doesn't keep it. So it was something called a ratio table, and it's a way to be able to track information. So we had the number of decks, right? And then you had the weight in ounces. So this is a model that you can use to track your information as you're thinking. And so like we had one deck was 3.2 ounces. And then like we went through, we got all the way to 10 and figured that was 32 ounces and so on. So the point of this string wasn't to necessarily work on doubling, it wasn't necessary to work on any of the specific strategies, but to help students be able to use a ratio table to kind of track and think of their ideas. All right. The last thing I kind of want to talk about these two problem strings. What kind of things did I do to kind of enhance the learning or move the learning along, or to kind of pause at moments? What are some of the things like either that I said or did that you guys saw? So like what teacher moves did you guys maybe see or observe during the problem strings? Jamie says that I called on people and used their names a lot. Danielle says I asked you guys to explain your thinking. Christy says questioning for inductive thinking. Susan says made a visual of what you heard people say as they said it. Gilbert says I allowed students to explain the way that they're solving. I gave time for everyone to think before sending the answers. Is there anything else you guys can think of? These are all great ideas. All right. So see that these are some of the other ideas that I had thought of, except in multiple right answers. So the first is that, and everything you guys have said so far are amazing ideas and all correct. Context. Naked calculations can be really, really challenging for students, and especially if you're trying to get them to start reasoning and thinking about numbers. Naked calculations can be really, really intimidating and are harder for students to reason through oftentimes. If you can give a context that really grounds students in information that they already know, especially with our adult students, they bring so much experience to the classroom that, and I'm gonna be honest, the card game, like the cards, it was a stretch. I'm gonna be honest about that, okay? But if you can really like get some context that really kind of connects to students and that they can own and that they can really then think about from use their real life experience, it makes those problems so much more accessible for them that they're not they're not trying to spend energy trying to understand the problem, but really they already understand it and they can start focusing on those strategies and thinking about the numbers and the relationships that exist between them. Thanks, Olivia. And yes, Marissa. Questions, like I asked you guys certain very specific questions as we did stuff. And I didn't have to do this, but sometimes when I don't get maybe what I'm looking for, like a certain problem string, I might write to actually just work on doubling skills. And if students use a different strategy, that's fine. I want to honor that, but that's not something that I want to take up space talking about in that moment because my focus is to like work on doubling. Okay, and so there were times when you guys gave lots of different strategies and ideas of how to do things, but I kind of kept close to that doubling strategy while that was being like built within that but within the deck of cards problem string, because that's what my aim was, is I wanted to pull out that doubling thinking. I can ask like if students, if none of the students actually did anything that you're trying to get them to do or that you're wanting to have a conversation about. And I say that because you're not trying to force them to like do another thing or another set of steps. It's really trying to build that thinking. There are some really foundational thinking skills about being able to do partial products. So breaking numbers apart to make them easier to multiply. We do that all the time with place value. If you do 72 times 8, you might do 70 times 8 and add it to 2 times 8. And so as you're doing that, that's a really important skill that some students already own and that others don't. And instead, they have to think about just 2 times 8 and 7 times 8. And then you put them in the right order for the algorithm, and they have no idea that it actually should like make a larger number because all you're ever doing is those single digit calculations. And so I'm finding that students have a hard time thinking about stuff that's larger than 0 to 10 when they're doing calculations and owning them. And so making sure you're giving them those opportunities to develop the various strategies is really important. And I also didn't have to use this question, so I wish I might not have it on there, but I did ask this in the very first one though, like, does anyone see something or do they wish that their brain would do something that they saw up on the board maybe the next time? Gloria, I think it was with you, like you were like, oh, I didn't ever think about it that way. I think it was with the subtraction problem string. And you're like, I asked you, did you want your brain to be able to do that next time? And you said, yeah, I kind of do. So being able to like also give students opportunities to know that if I'm not doing that now, just because Adam can do this really cool thing, right? Or Olivia can do this really cool thing, doesn't mean I can't do it. It just means that my brain's not doing it now. And I have to, kind of throw that idea on the back burner for now, but maybe the next time I see a problem, it's going to jump out at me. And I want to keep that kind of in my brain to be able to think about, okay, well, I can't do it now, but I can do it in the future. So there's that growth mindset there that we're developing also in class. Being able to celebrate creative thinking. I think one of you guys mentioned that, being able to like see the multiple strategies and be able to talk about them. And I try to de-emphasize the answers. Now I asked for the answers. It's something that I'm shifting in my own class. And so it's a really hard routine to break as I was starting to develop my skills in doing problem strings. But the idea of asking, instead of did the problem before help you solve this problem, but asking, did anyone use the problem before as you were thinking about this problem? So again, the idea that you don't have to arrive at an answer necessarily yet, but were you able to think about this problem and get started? Were you able to make some progress? So even if you didn't get to the answer or get to the correct answer, were you able to start that train of thought? And then the kind of models that I was using to help student thinking make it visible. One of you guys talked about like the fact that I was making student thinking visible. So as you guys shared your ideas, I tried to show it on the screen through the ratio table or through using a number line. And so models can be a really important tool that students sometimes don't always own yet when they're doing their own thinking. And so when we ask them to show their work, a lot of times it's really challenging. And so as the teacher, your job is to help model that, show it to them. This is how you can show your thinking. And they may not need to show their thinking always for easier problems, but modeling it for those problems for the students that already can just do it in their head is helpful, because then they can see, oh, that's something I can use when I get to a problem I might get stuck on. I know how to use that new model now to be able to track my thinking with problems that are more challenging. Okay. I was going to give you guys a break, but I'm looking at the time, and if I do that now, we won't get to other stuff. So the conversations we had were amazing, but they got really long, and I'm trying to decide what to do. Hold on. Yes, I know. Okay, I'm going to make an executive decision, and we're going to skip over some stuff. Yep. So I'm curious now, after seeing this, how likely are you to use problem strings in your class now? So Gail, if you are able to put that up in a poll, I know we went out of order and I apologize.
Nope, I've got it.
Thank you. With 1 being very unlikely and 5 being very likely, how likely are you to use problem strings in your class now?
Was everyone not able to see it?
I don't know. Are you guys able to see the poll? It should have popped up in front of you guys.
Yeah, but there's nothing to press on or something. Like, hold on.
Oh, weird.
Really?
Yeah, I can see it, but then when I pick my number, it won't take it.
Oh,
Yeah, right.
well, I'm sorry about that. Okay, well then let's continue and have people go ahead and do it in the chat, and we can just
Yeah,
look at
thank you
that.
for
I'm sorry
rolling with
about
it,
that.
you guys.
Sorry. Oh, I see a lot. Yeah. And I tested it before. It must not have rebooted.
All right. So my next question then is, oh, sorry, I got to get rid of the poll screen.
Got it.
Yes, Jamie. So my next question is yes, how do you plan on using it? And if no, what barriers do you anticipate or what resources do you still need? So if you guys need anything from me or if you have questions about it, please type them in the chat and I will try to spend the rest of the time here answering your questions, okay? So Jamie asked, are there variations of strings or a resource that you use to make these? Yes, there are. So there's a problem string hub. And if I am correct, this is going to become a PDF and it will be something that you can click on all of these links. Okay, so there's a problem string hub. There are free problem strings for you to use. I wanted to do a fraction one. I know one of you guys said you wanted fractions. Time went by really, really fast. And they have addition, subtraction, multiplication, division. They have proportional reasoning ones. They have percents. They have a variety of problem strings. Yep, measurement's a really powerful one to do it with, Jill. Susan, that's a really good question. I don't have a ton of experience in that. I know that there is an answer to that. If you send me an email, I can get a better answer for you.
Yeah, because it's, oops, sorry.
There is my email. Yes, Olivia. I've used problem strings as either a warm up to a certain topic, or if there's something that I'm seeing students need like more experience with and they need some support in connecting ideas. Problem strings can be helpful for kind of solidifying that either at during the lesson. It can be used as a preview to a lesson if you're wanting them to get some experience with certain numbers that might show up in a word problem or in a task. It can be a good wrap up at the end as well to kind of solidify ideas that maybe a task got to, like if the group is working on being able to multiply by 10 and seeing that multiplying by 100, like what that does for place value, you can use a problem string at the end to kind of solidify stuff that you've been learning throughout the lesson. I'm trying to see what other questions you guys have had. So some of the materials are free and then some of them actually do cost money. Pam Harris and Kim Montague are two people that have developed a wealth of knowledge on the website Math is Figureoutable. And they have lots of free resources. For example, if you're wanting to know specifically more about problem strings, even after today, there's a podcast. Their podcast number 71 is an episode specifically all about problem strings, and they talk about it. They have different textbooks. They have textbooks with problem strings that support algebra. And so if you're looking at graphs, if you're wanting to talk more specifically about like linear graphing and things like that, then those books might be more like helpful in that. And you can use it with lots of different content and switch that out within the problem string itself. So you can use fractions. One of the problem strings I was going to give you guys, just so you can preview it. was about how many eggs do I have? And giving the visual of being able to talk about like a third of 18. What's 2/3 of 18? What's 1/6 of 18? What's 5/6 of 18? And being able to go through and talk about fractions as like operators, so fraction, like a fraction of a number. And this is a really tangible way to do that, where students really do have experience in this, and they can bring that experience into the problem string. And rather than trying to use all their cognitive load or have the cognitive load be on trying to figure out like what the context is, it's more on figuring out what does this really mean to have 1/3 of a number. It's the only free picture I could find. Don't judge me. Danielle had asked what's with the one brown egg. All right, it is 3:28. Are there any last questions? Well, it has been a pleasure working with you guys today, and I thank you for sticking around. I know that it can be a long day, and I hope that you guys found this helpful.